All right, this is the lesson video for Math Models, Unit 2, Lesson 1. This lesson, a lot of this should be review for you because you've been graphing points on the coordinate plane probably for a long time in your math careers. But just to kind of start by giving some basics about this. Nope, wrong note. There we go. The things that you need to know about the coordinate plane. Remember that when we're talking about this, we're talking about graphing points in terms of their x location and their y location. We have our x-axis that goes horizontal, positive over here, negative over here. We have our y-axis going vertically, positives up here, negatives down here. We call the point in the center where they intersect the origin, and it has coordinates of 0, 0. And then each quadrant has positive and negative values depending on what the x and the y are. So the quadrant 1, this section up here, always has a positive x value and a positive y value. Quadrant 2 always has a negative x value and a positive y value. Quadrant 3 always has negative and negative. Quadrant 4 always has positive and negative. So we could graph all sorts of points on here just to kind of give a couple examples. This point right here would be 1 on the x and 3 on the y, because it's 1 and then 1, 2, 3. So that's the location of that point in terms of x and y. We also could have a point, let's say, right here. This point would be negative 5. Oops. Negative 5 and positive 3. Because again, we have negative on the x and then positive on the y value. So hopefully that's familiar to you. And so a lot of what you're going to be doing at the beginning of this is just going and finding those values. So I'm going to actually clear the screen here. And let's go back to our lesson. So that's kind of the first thing they have you do, just to give you an idea. Match the coordinates to their points. In other words, point A, what are the coordinates of point A? I know this is a little bit small. I'd recommend zooming in if you can on your chart so you can see. They only have 2 and 4, 6, 2, 4, 6, 8. They only have the even numbers marked, but this would be 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So A would be 3, 4. So that just gets you started. And then you're just naming the points for all of those points that you see right there. So that's what you're doing for number 1. Just match the coordinates, find the correct coordinates. So like for that one, we said it was 2, 4 or 3, 4. So I would choose that answer choice. You need to do the rest. So note, if it's C, for instance, that has to be negative, negative, because that's in quadrant 3. So use that information to your advantage. This is maybe even simpler than that. You need to say which points are in each part of the graph. Quadrant 1, 2, 3, 4, and then on the x-axis and on the y-axis. So which points of that group are on the x-axis and on the y-axis. So for instance, like I just gave you the example, we see that point C is in the quadrant 3. So I would go here and I would choose point C as the one located in quadrant 3. Again, I'll let you do the rest. Those are pretty straightforward. After that, more matching the coordinates. So you find the x and y coordinates for point M and point N. Okay, then it switches gears to this idea of dilation. And they don't do a great job of explaining this, but let me kind of try to give you some information about this. The idea of dilation is like you have some object and you are going to make it larger, but it is going to remain in the same scale. So for instance, in this example, this might be 3 here and 2 here, and then this would be 6 and 4. So both of these have been multiplied by 2 to get to the new figure. So this is dilation, and then we would say it's by a factor of 2. So in other words, I'm multiplying everything from the original figure by 2 to get the new figure. You could also do it to make something smaller. So for instance, I might have a circle, I should say that, and then I have a circle like this, and I might say that this radius is 4 and this radius is 2. And so in this case, how did we get from here to here? We multiplied by 0.5 or 1/2. And so this would be dilation by 0.5. And so your dilation factor, or the scale factor is what this is called. The scale factor tells you what you multiplied by to get from your original to your new figure. So for instance, it says Tori went to the eye doctor. He dilated her pupils to twice their normal size during the exam. If her pupils were 2 millimeters originally, what size were they after being dilated? It tells you everything you need to know. We can see that we have twice the normal side, that's times 2, and we have the original amount. So we should be able to use that together to do something very similar to what we did here in the first example I gave of dilation. Let's see if I can get this to zoom out here. Sorry, I'm trying to zoom out. There we go. There we go, clear. All right, so that's what you're doing there. Same thing in number 5. Blueprint for the model of a new garage have a scale factor of 1 inch equals 4 feet. If the garage is to be 18 feet long, what is the length of the model? In other words, what number of inches times 4 will give me 18? So now we're actually working in reverse. So if you want to go from 18 feet long down to the number of inches, you need to divide 18 by 4 to get back to 1 inch. Because we are going from the feet back to the inches. That was a little bit weird, which is why I kind of just spelled it out for you. But you should definitely be able to do number 6. You need to apply a factor of 0.75 to each one of those numbers, and you need to find 3 answers that correspond with the answers you get when you multiply those by the scale factor. All right. The next thing I have a little notes page for. So that's dilation. Now they're looking at reflections. And so the idea here is that we're taking a point and we're saying, what if I took a line, this line right here. Oops, my bad. Darn it. Okay, there we go. Let's go down. There we go. What if I took this line right here, for instance, and I said, where would this go if I made this a mirror and reflected it to the other side of that line? It's pretty clear it would be right here, right? So the point 2, 3 would become the point -2, 3, okay? And so that would be what we would choose for the answer here to the y-axis. So I'll just show you that one as an example. -2, 3 would be our answer. Now, you can do that visually if you like, but I did put in the notes an example of the basic formula for each one of those moves. So what this is telling you to do is that if you're doing this kind of reflection, like for instance, a reflection across the x-axis, you need to make the y value negative. The x value stays the same. If you want to reflect across the y-axis, the x value becomes negative, but the y value stays the same. If you want to reflect across y equals x, then you switch the y and the x. You can see that over here. So these little things are telling you what to do if you're trying to find that. So here, x and y switch places. And if you want to reflect across the line y equals -x, you make both values negative and switch them. So you can do this to the numbers you start with to get the final answer. And that's what you need to do here. So I've kind of already told you, or they tell you, this point is 2, 3. And then they're asking you to apply all of the following changes. And those 4 things are the 4 things on this notes page. So you need to apply each one of those rules to the numbers in the original XY point. Do it 4 times. You'll have 4 different answers. That's what you're doing in number 7. That is what you do when you do reflections. Lastly, I think this is all there is. Yep, 4 questions, all dealing with translation. I'll do one of them. A translation is basically telling you what to do to the x and the y value. So if I start with -9 and 6, and this tells me to do 5 and -2, I'm literally adding that essentially. So I'm taking these values and I'm combining these. Those are the x's. -9 and 5 combined to make -4. And then I'm doing the y's. 6 minus 2 is 4. And so this would be the new value. So literally all you're doing is taking that, what they call a vector, and you're taking this vector and you're changing the x value and the y value, the amount stated in the vector. So the vector is arranged the same way, xy, xy. So you just add or subtract those together, and that becomes the new value for the point after it has been translated. All right, so that's pretty much it. That gets us to the end of that lesson. So that is it for lesson 1.